Now we're going to explore the concept of forcing bits in a PLC. Right now I have a very simple program entered into my MicroLogix 1000 PLC. I have a normally open, or what they call examine if closed, contact running over to a output enabled coil, so that when this bit is set, it's going to pass imaginary power over to this imaginary coil. It's going to set the output bit 0 and turn it on. And so running this program, we come over here to my PLC and we see here's my input bit 0 switch. So I turn that on, the light lights up for input bit 0, in output bit 0 also lights up right along with it, so I have direct control over that one bit. It's a very, very elementary program. It's about as simple as I can make it with contact and coil programming. So next thing I'm going to do is take a look at the data files and examine what's happening here with our bit statuses. So here's my input file, and then here's my output file. And drag this over. I'm going to lay the output file box right on top of the input to get a better view of what's happening with those bits. Since I'm only dealing with input element 0 bit 0 and output element 0 bit 0, I'm only going to focus on these bits here highlighted in blue. As I turn on my switch, you see that bit's going to turn to a 1. That will close the imaginary contact here, sending imaginary power to my imaginary coil. That's going to set the bit in the output file, and that's going to drive the output and make it so the output to channel 0 is going to be able to pass electrical power to some real device. So once again, turning the switch on and off, we see the status change in the program, and we see the bits change right here. I want to show you what's known as a force. If we go down over here to the left-hand pane and we examine where it says force files, I'm going to go to the output and drag this over here. And here's where I can actually force that output bit to be something other than what the program tells it. So in this case, I've got my input switch turned on. That is setting bit right here for the input, passing imaginary power through that imaginary contact with the imaginary coil, and that's setting the output bit and turning the output on. But if I want to, I can go down here to force, and I can highlight this bit right here and enter a 0 and force it to actually be a different state, something other than what the program wants it to be. So in this case, I have a force that shows up here in my force window. Over here, you notice on the data file output, the 1 status that you see for that bit is highlighted in red. That's telling you, hey, I've got a force going on. This is not the real status that we see here for necessarily for that bit. This is what the program is telling that bit to be. This is what that bit actually is. And if we pan over to our PLC, we see some interesting things here. We see my input switch on. I'm still energized on input bit 0. I am no longer energized on output bit 0, and I have a new light on my display, a light on the PLC that says force. If I turn the switch on and off, you'll notice the output bit does absolutely nothing. It has been forced to a 0 state, no matter what the input does. Now looking over here at the program, panning back to this, I will take my input switch and turn it on and off and watch what the program does. The red highlighting you see here showing the imaginary power is still turning on and off as I turn that input switch back and forth. And in fact, you see right here on the data file output, you still see the 0 and the 1 back and forth as I turn the switch on and off. That 1 bit remains highlighted in red, telling me I have a force condition going on, and no matter what value is being written here, that value is being overwritten by a 0 just prior to the part of the scan cycle where the PLC writes those bits to the actual hardwired output. So I have forced the output bit in this case to be a 0, and it's remaining a 0 no matter what my program's telling me. This is a bit deceiving because you look at the colored highlighting on the program showing you imaginary power flow, and it appears that it's working just fine. The only indication on the ladder logic itself is what you see right here, a word in red that says off. That's telling me that I have forced that output to be off no matter what the imaginary color highlighting is suggesting it might be. This is useful in troubleshooting if you absolutely need to set or to reset the output of the PLC to a particular state. It can also be dangerous because you are overriding the will of the program. You are manually overriding, manually taking over the status of the output. which can cause bad things to happen if you don't know what you're doing in a real system. I want to show you can also force the output bit to be a 1. So I'm going to enter number 1 here. And I have now activated or energized my output on the PLC. Well, notice once again as I turn the input switch on and off, we see the colored highlighting for the imaginary power flow here. We also see on the output word, the output file, that 1 bit is going back and forth between 1 and 0 as I flip the switch on and off. It remains highlighted in red, telling me that that bit is forced. And down here in the force table, I see the value it's forced to, which is a 1. If I look up here in the program itself, my other indication that there's a force going on is the red word here says on. So I have forced that output bit to be on no matter what the program wants it to be. Again, handy for troubleshooting, useful for diagnosing problems, but dangerous if you don't know what you're doing, because in a real process I'd be overriding or forcing that bit to be on regardless of what the program wanted it to do. And once again, panning back to the PLC, I see the output is on no matter what the input is doing, and I have a force light that comes on telling me I've got a force condition. I can clear all my forces or remove them all by clicking this button under Remove All Forces. If I do that, are you sure you want to remove all forces? Yes, I am. So once again, return to a more normal display. We see here, as I turn the input switch on and off, the program's working like it should. I don't see any red highlighting in my output file table. And over here, I show dots instead of a 1 or 0 for that bit, telling me I'm no longer forcing anything here. And my program works like it should. Panning back to the PLC, as I turn the switch on and off, you see a direct correspondence once again between that input bit and that input bit, that output bit right there. You also see the force light is off. We're no longer in a forced condition. So the program is acting normally as it should. And that's how we use a force on an output bit.